Design principle. Okay, so there are scenarios when we follow all the measures, we follow all the guidelines, still we fall in trouble. Means things should be finished. When we start something, then we should know stuff till the end. So that is the scenario. We learned about open close principle. Then we learned about Liskov's substitution principle. Then we learned about interface. Uh, okay, so uh, dependency inversion. So we learned about open close, Liskov substitution, dependency inversion. So we started with the open close in a way that a program, if I write, either I write a function, I write a class, then once it is completed, then it should be closed forever. If someone wants to make any modification, it is open for extensibility or it is open for containment. He can contain it and delegate the calls, or he can derive from it and then he can extend the operation, he can override the operations, or he can reuse some of the functionality and he can create a mixture of whatever he wants. But once function is finalized, once class is finalized, then it should be closed for modification. Then we saw Liskov substitution. If I am writing code through a class, then I have derived classes through it. Then derived classes should exactly substitute the base class. So in the implementation, wherever we see the base code written with the base class pointer, if any derived class comes into the picture, it should exactly overlap, it should exactly substitute the base class. Then we saw the dependency inversion principle. That if a class is dependent upon a particular class, higher class depend upon a lower class, then this dependency should not be direct. We have to introduce an interface, and the lower level class would realize the interface and higher level class would depend upon the interface. So higher level class depend upon the interface and lower level class derive from the interface. So higher level class and lower level class, they are decoupled, and through interface, since they are attached to an interface, so there is a good uh, chance of some kind of understanding, so fixed understanding. So nice, means we have understood all three concepts. Now what is next? Suppose that I am dependent upon a printer. So printer is a class and I am dependent upon the printer. Printer takes printout through communication, like through email. So printer is a class and it has methods to so kind of send document. Then then I set the document formatting, A4 whatever I want, A4 size. So document format I set, I send the document, then fire print. Then I say, then fax these pages, then I say staple it. So there is a class called simple print class. So printer gives a class. So now I am following dependency inversion principle. So printer class I'm not going to use as it is because there should not be implementation coupling. This is what we have been seeing. So if you want coupling, then coupling should be through interface. Now printer is a class which prints the data. Then there is an interface class called iPrinter. So printer derives from iPrinter, implement the iPrinter. Now my full code is written through dependency inversion principle and my full algorithm is written through iPrinter point. Now I select the format, I send for printout, and then okay, so selecting format is A4 format that is available now. So the method is for A4. Then I send for printout means I send email through email. So the method is for email. Then I fire print. Then I fire for fax. Then I fire for stapling. So now code is clean cut and everything is nice. What is problem? Now problem is that suppose that if I am selecting the formatting A4, tomorrow A44 new format came. I am sending document through email, but Bluetooth is also supported. Okay, and now I am sending for printout. Then I am sending asking for sending it through fax. Okay, email sending is also possible. Okay, then stapling it. Okay, then putting to a kind of book formatting is also an option. A spiral binding is also option. Now, all all new functions sending through Bluetooth or formatting through A44, and then rather than stapling, making a book print, and then sending through email, not through fax. All new methods came in the iPrinter itself. So iPrinter is an interface and it is following nicely the dependency inversion principle. Everything is okay. But printer class has unnecessary growth in so many roles. Okay. So printer has so many roles. Can we see now? Printer has a role for formatting. Printer has a role for sending data to the print, means communication. Printer has a role for printout. Printer has a role to sending fax or email. It can grow in any fashion. Their parameters also may change. Printer has a role for making a staple or making a book binding or a spiral binding. So, can we see now that the role what printer is supporting? Okay, the roles are orthogonal. That is the main thing. Okay. Now, if I talk about the coordinate system, then we have x, y, and z, I, j, and k. All three axes are orthogonal. Orthogonal in the sense they are, if one is changing, other has no dependence. It is 90 degrees. So this is orthogonal. If there is a variation in y-axis, there may not be any variation in x-axis or z-axis. They are orthogonal to each other. So if I have a class and it has a kind of functionality, roles which are orthogonal to each other, then they are not dependent upon. So we are talking about interface segregation. So can we now, anyway I had interface earlier, iPrinter, can we now subdivide the iPrinter into different interfaces? Now, if I don't do that, then in the algorithm, so algorithm if I have written to first do the formatting and then uh, send it through the email, later Bluetooth scheme. But so my all the way is sending through email only, then asking for printout, then spiral binding, and then stapling, and then sending fax and stapling. So this side, the client is implementing iPrinter and print class, the printer. It is also when it is writing the code, there also it is completely mixed up. I am not saying that one method should not call other method, but method should be cohesive. Cohesive in a way that they should be kind of whatever uh, uh, the features, the methods, whatever they are highly related to each other. Changing one place may change other place. Those related to each other, they are not orthogonal to each other. They should be only interrelated. Now, if I see the printer class, then the formatting, sending it to printer, taking the printout, and then sending via fax, okay, and then stapling it. All are different rules. Okay, so now in the client side, when we are using the iPrinter, there, if new things come, then I start putting if and else. So now, how do you want it to be sent? You want it through Bluetooth or you want through email? You what formatting you want? A4, A4, what kind of a stapling you want, book printing, a spiral or stapling, what how other any other guy need to be notified, then how it will be fax or email. So these are the things that should be asked, will be asked on the client side also, and again code mix up will happen on the printer side also. If one thing, one logic is changed at, so we have different roles. One role is that we are, one role is that sending to formatting, then sending to the printer, taking printout, then informing, sending the through the fax or whatever printout has been taken, or informing someone, and last one is stapling it. Now five different kind of role. If anything, anywhere little bit changes, everywhere I need to change. So for small thing, hours or week will go in modification. So we are following all the principles: open, close, list scope, substitution, dependency, inversion, but still heavily lacking. So all the rules which are orthogonal to each other, we have to separate into interfaces, different interfaces. Now, now, formatting is a separate interface. Sending it to communication is separate interface. Taking printout is a separate interface. Informing users through fax or email. So only one interface means sending, formatting one interface. Then one interface for sending printout, one interface for taking print, taking firing the print, one interface for informing other, one interface for stapling. Five interfaces have now come out. Now I have written the client code using these five interfaces. This is interface segregation. Five interface pointers. Now if any user wants Bluetooth, then in the communication interface he will pass the Bluetooth object. That's it, because methods will not change. If he wants A44, he wants A449, new formatting has come. A49 object he will pass. That's it. Because methods are same. For printout, he will use the iPrint and methods are same. For taking a stapling, he will use a kind of binding, but methods are same. So object what he would pass is a spiral binding or book binding or stapling. Informing others, so I inform, he will use it on the client side, and then I inform at the runtime. If it is a fax, then fax object will be passed. So from I inform, fax, email, and these will be derived. From the I communication, email, Bluetooth, and these will be derived. From the formatting A44, A4, A44, A49 will be derived. From the binding, staple binding, book binding, spiral binding will be derived. From the printout, if more printout printers come, then those printers will be derived. So now my client code is closed for modification. It follows list of substitution. It follows dependency inversion. Now it follows interface segregation. Okay, and in the printer side, now they have implemented these interfaces, and so there is a class which implement these five interfaces. Now it depends upon what is the runtime class that comes into the implementation. So they have to bother about that one. Clean on client side, clean on server side. Everywhere it is highly clean. So please start using. Okay, so what is the design pattern that is used here? Strategy design. Again, so strategy design pattern is a marvelous design pattern which is so good in using list call, substitution, open close, and dependency inversion. Now, interface segregation. So it was receiving one interface earlier as a function pointer. Now it is receiving five interfaces, but each interfaces are subject to extended into many runtime objects, polymorphic objects. So clean, so cut. What else someone needs? Means it is a kind of close of the story. So we are in discussion for a solid SOLID design principle. So S is for single responsibility that we will discuss. Okay, so O for open close, L for Liskov substitution, I for interface segregation, and D for dependency inverse. So four we have discussed. So start using it. Means we can do in ATM's kind of machine also. Like ATM provides functionality for money withdrawal or money deposition. Okay. So if tomorrow if money withdrawal, if ATM machine changes or way to withdraw the money, way to deposit the money, those things also new things start coming. Then rather than having one ATM class or IATM interface point roles, we will per role wise we will have interface different interface like deposit the money, that is different interface. From there we will have the actual concrete classes. Okay, withdraw the money and then checking the balance and mini statement. So checking the balance will have many way. Earlier it was just checking the balance. Now mini statement or history for 2 months. So these are should be accessible through separate role interfaces, and then anyone whatever it wants in the algorithm, you want history, then he can pass history object that would confirm, that would realize the checking the taking the printing the statement. So it can be history or it can be uh, kind mini statement. It can be just the how much money it has, like that. So ATM or anything which has so many roles, and each role would grow in its own fashion tomorrow. So rather than having everything dumped in a class, each role will have different interface in the dependency inversion. So now it came to interface segregation. Please use a strategy design pattern and use interface segregation.